Today I'll be talking about how to name alkynes. So alkynes are a class of compounds which have triple bonds and they're hydrocarbons. And there are two types of alkynes, and I have a model right here. Let's look at this particular example. This gray atom right here, these two are the atoms of the carbon atoms, and pink is the triple bond indicating the triple bond. So since this triple bond is within the molecule, so it's called internal alkyne. Now, of a terminal alkyne, the triple bond is at the end, as in this case. So you can see triple alkynes which are at the end will bear or will have a hydrogen attached to the carbon triple bond, to one of the carbon triple bond, whereas in the internal alkyne the triple bond carbon atoms are not attached to any of the hydrogen atoms. So from an IUPAC naming convention, alkynes are named from alkane. Alkane is the parent, and in this case you just replace the alphabet A with the alphabet Y, and from alkane it becomes alkyne. So one thing that you need to remember is the ranking of the functional groups. So if there is a halide, halogen, and a triple bond in a molecule, then the triple bond will have preference in the naming convention. So let's see how to name functional groups as substituents of the parent chain. So you will encounter different functional groups. The most commonly encountered are halides. Whenever you see a halide, then they can be named as fluoro, chloro, bromo, iodo. Iodo comes is for iodine, and bromo is for bromine. If there is an alkyl chain like ethyl or methyl, they are derived obviously from alkane. You take the alkane name and you replace the ane with YL, and that's how you get the name ethyl. So ethyl comes from replacing the ane in ethane with YL. Similarly with cycloalkanes, when they are substituents, they are called cycloalkyl groups. So example is cyclopropyl, cyclobutyl, cyclopentyl, and so on and so forth. In case of alkynes, when alkynes are substituents, then they are called alkynyl. For example, when a triple bond is a substituent on the parent chain. So in this particular case, I've kind of highlighted when you lose a hydrogen, the cycloalkane becomes cycloalkyl, and similarly with alkyne, it becomes alkynyl. So let's look at the IUPAC and the common names of some of the alkyl groups observed in organic molecules. So I have covered this in a whole lot of detail in my previous video on naming of functional groups. Please refer to that. That would be helpful for you to understand, but I'll quickly point out a couple of things. A and E is replaced by YL, so it becomes alkyl. And you have branch chain alkyl groups, so these are all branch chain, and you have the straight chain like ethyl, methyl, and you have a propyl here. In parentheses, the name is the common name like T-butyl. From a naming convention, you have to number the carbon atom that is attached to the parent chain as number 1. So in this case, this carbon atom will be numbered 1. This is the carbon atom, and to this carbon atom you have the 3 methyl groups. So you have this carbon atom and then this. So this is the ethyl. side chain, and to the ethyl side chain are two substituents. There are two methyl groups as substituents. So it's called 1,1-dimethyl ethyl. Di because there are two methyl groups, and 1,1 because they are attached to carbon atom 1. So that's how you kind of name this particular. So I've made a model, and sometimes it's kind of useful to look at models. So this is a model of T-butyl. You can see this is 1, 2, 3, three methyl groups. This is the central carbon atom, and that is attached to the parent chain. And these models can be, you can make it, and I've made it using the organic chemistry basics set from the company called Maruzen. It manufactures these models, and it's sold everywhere. They also have nice p orbitals, so it's kind of useful to understand, and learn more about organic chemistry, making models to understand how the reactions, why certain reactions occur from one side or the other, and to understand even the radical and carbocation chemistry. So another example that I wanted to point out here is the neopentyl group. So in case of a neopentyl group, and this is a neopentyl group right here, and this is the CH2 group that's attached to the parent chain, and it looks like this in on paper. So this is the neopentyl group, and this is the common name neopentyl, and its IUPAC name is 2,2-dimethyl propyl. So you can see that it's 3 carbon chain, 1, 2, 3. So that's the reason it's comes from the propane. Since it's a side chain, it's called propyl. And then there are two methyl groups attached to carbon atom 2. So this is carbon atom 1, this is carbon atom 2, this is carbon atom 3. So 1, 2, 3, and then these two are the substituents on carbon atom 2. That's the reason it's called 2,2-dimethyl propyl. Neopentyl group is the neopentyl is the common name. So let's move on to understand the IUPAC rules for naming alkynes. So first thing to do is to locate the longest carbon chain, and this is considered the parent chain. And if there is a ring in the molecule, then the ring has preference over the parent chain, and the ring will be considered as the parent, and everything attached to the ring is considered a substituent. So if both carbon atoms of the triple bond are in the ring, then it is named as alkyne. If not, then the triple bond is considered to be a substituent on the parent chain. So any group like halide and alkyl group are considered as substituents. So if the parent chain is the alkyne, then you start numbering it from the side, or from that end, which is closest to the triple bond. In case of a symmetric alkyne, then you look at the substituent, and you give the substituent the lowest possible number. So you'll kind of number it from the side so as to give the substituent the lowest possible number. So if you have more than one substituent that is the same, like if there are two methyl groups or two ethyl groups, then you'll use prefixes such as di, tri, tetra, penta, and so on. If there is a branch substituent, then the carbon atom of the branch substituent that is attached to the parent is numbered as 1. If there are several triple bonds in the parent chain, then again use the prefix di, tri, and always indicate the location of the triple bond, each and every triple bond. So finally, in order to name the organic molecule, you'll start listing all the substituents in alphabetical order. Remember to add the numbers in front of the substituents to indicate the location of the substituent. And finally, add the name of the parent. So let's look at some examples. So let's look at this example. So in this particular case, this is the 1, 2, 3, 4, 5, 6. So this 6 carbon atom chain, but there's a ring right here. So whenever there is a ring, the ring has a preference, and so this whole is considered to be a substituent, and this is the parent. And so that's the reason this is called 2-fluoro-3-ethynyl hexyl. Hexyl because this whole chain is considered, the 6 carbon chain is considered a substituent, and on this substituent are fluoro and ethynyl substituents. In the location of fluoro is carbon atom 2, and of ethynyl is carbon atom 3, and then you end up with the name cyclohexane. Let's look at another example. So this is a cyclic compound. This is cyclopentane because it's a 5-membered ring. You have 2 substituents on it, 1 chloro and 1 ethynyl. The substituents, if you recall the convention of the wedge line, this is the wedge line and this is the hashed line. The wedge line means it's above the plane of the cyclopentane ring, and the hashed line is below the ring. So these 2 substituents are on the opposite sides of the ring, and because of that they are considered to be trans with respect to each other. Please refer to my video on classification of isomers. You'll see the geometric isomers where this is trans to better understand how to name this. So the substituents are chloro and ethynyl, and the numbering is always, you always start from alphabetical. So in this case, chloro is alphabetically first as compared to the ethynyl, and so you start numbering from here 1, 2, 3, 4, and this will be 4 and then 5. So it's called trans 1-chloro-3-ethynyl cyclopentane. So let's look at another example here. There is a ring, so the ring will have preference. I've numbered the side chain. This 1, 2, 3 is the side chain. On carbon atom 1 we have the iodo substituent, and so this will be called 1-iodo-2-propynyl cyclobutane. And then you have this final example right here. The numbering is starting from here, this carbon atom 1, 2, 3, 4, 5, 6, and 7. So it could be this 7 or right here 7, it won't matter. You have 2 methyl groups, 1 methyl group on carbon atom 3 and another methyl group on carbon atom 6. There is a triple bond as a substituent on carbon atom 4. So this is the longest parent chain 7. So if you had numbered it from 1, 2, 3, 4, 5, 6, so 6 is smaller. So that's the reason the triple bond is not a part of the parent chain. So you have 2 methyl substituents and 1 ethynyl substituent, and so you number it as 4-ethynyl 3,6-dimethyl heptane. You use the word di because there are 2 methyl groups, and this is the 3 and 6 are the locations of the 2 methyl groups, and then you end up with the alkane name, which is heptane, because that's the parent chain. Let's look at another example. In this particular example, you have, this is a terminal alkyne as well as an internal, because terminal because the triple bond is at the end of the carbon chain, and internal because it's inside or within the carbon chain. So you start numbering. In this particular case, you have just a triple bond, two triple bonds and a bromine. So remember the naming convention, that triple bond has a preference over bromine, so you will start numbering from the side which is closest to the triple bond. So 1, 2, 3, 4, and so on and so forth. And you have bromine is considered as a substituent on the parent chain, and you number this as 7 bromo 1 5 heptadiene. So you indicate the location of both the triple bonds. The location is carbon atom 1 and carbon atom 5 have the triple bond, and you use the word di because there are two triple bonds. So thanks for watching. Like and subscribe.